Again, yeah, hello and welcome to this follow-up talk for the mirror daemon. So the earlier talk, we saw mostly the interfaces and how things tie up into the manager module, the mirroring module, and the inner workings of the mirroring module. So this talk is about the daemon itself, the daemon which actually does the synchronization of snapshots between the primary and the secondary cluster, file systems in the primary and the secondary cluster. So the CephFS mirror daemon is one per cluster, which means the mirror daemon can handle multiple file systems. Since CephFS is multi-FS ready, so it made sense to handle multiple file systems. So you need just one mirror daemon for the entire Ceph cluster. And the mirror daemon needs to be run on the primary cluster. This AND is based on a push model. So the data is pushed from the primary cluster. The snap data is pushed from the primary cluster up to the secondary cluster, file system in the secondary cluster. And the mirror daemon uses libCephFS, so it's a normal client application. It uses libCephFS to talk to both local and the remote cluster. While designing this, we had thought about doing mounts in the primary and the secondary cluster so that we can use rsync, use the diff algorithm in the rsync to kind of only synchronize the diffs between two directories or two data sets. But that's an overhead of maintaining the mounts and a lot of things. So is that switch to using the CephFS client library, libCephFS, and we do support incremental synchronization of data. But if right now in Pacific, that's not there. In the sense, whatever is available in Pacific right now is like a bulk copy, is like transfer the entire thing, entire everything inside a snapshot. So if you are transferring another snapshot, so you delete the directory on the remote file system and then copy it again. So a quick point about how snapshots are synchronized. For a given snapshot, everything under the snapshot is copied over to the remote file system for that particular directory, and then a snapshot is taken with that particular name on the remote file system. So that ensures its snapshot names are in sync. So so right now in Pacific, as I tell, it's a remote copy, but that is not that performant and it's slow. So we have a PR work in progress that switches to usage-based incremental based synchronization based on inode, mtime, and ctime. So the code that I'll be showing you today, that I'll be walking you through today, is the incremental based snapshot one. The bulk copy is not much interesting. The only difference in that is, it's a remove call followed by a bulk copy call. But we'll see how the incremental synchronization is done. So so as I said, it's a normal libCephFS client library, uses libCephFS to talk to the local and the remote cluster. Which means for the mirror daemon to initialize the libCephFS handle or to connect to the cluster, it either needs the Ceph configuration file to be present on the host where it's running, or it needs the mon header and the mon address and the keyring and the username to connect to the cluster. So for the primary cluster, we expect that the Ceph configuration file for the primary cluster is available on the nodes where the mirror daemons are run. For the secondary cluster, we have two options. So the secondary cluster is what we call as a peer to the primary cluster file system. So we support two ways of adding a peer. One is via a peer add interface, and I think I covered it in the first talk. So the peer add requires the secondary cluster Ceph configuration file to be present on the primary cluster. And the keyring to be present on the primary cluster. But there's another way to add a peer, which is what is recommended, and that's called bootstrapping a peer. It's like bootstrapping appear on the remote cluster and then importing it on the primary cluster. So the Bootstrap create creates a token, which is nothing but kind of a digest, X digest of the variables that are required to connect to a cluster, which is like the monitor address, the username, and the and its keyring. So that creates a token, and then we use that token to import it, to import that token in the primary cluster, which is like adding a peer again. But at this, when you do a Bootstrap-based peer addition, you don't require the remote clusters Ceph configuration file and the keyrings. So we'll see that how that's done. Okay. And yeah, so for Pacific, we only support running a single mirror daemon. You could possibly just run multiple mirror daemons, but that is currently untested. So we recommend just running one. And yeah, so let's see. So it all starts up with, good old main.c source. We do basic initialization here, just like creating a messenger, creating a mon client, and doing some demonizing things. That's probably the only thing we'll do here. Nothing much interesting here. So yeah, it all starts with cluster watcher. So if you recall from my previous walkthrough, all the peer changes and the peer updates are stored in FSMap, and even the what file systems have mirroring enabled. All those details are stored in FSMap. So the first thing that when a mirror daemon spawns is subscribe to FSMap, because it needs to know what is available, what file systems have mirroring enabled, and what peers are added. So cluster watcher is used for that. It's nothing, it's pretty simple. You just subscribe to FSMap and you get notified when there's an FSMap update, which is here. So we do a handle FSMap. We come to handle FSMap. It's pretty simplistic. You just walk through all the file systems available in FSMap, and you see which has mirroring enabled. If it's or mirroring disabled, so it had mirroring enabled again earlier, and now it's and now the mirroring has been disabled, and you kind of figure out which file systems need to be enable mirroring and which needs to be disabled mirroring. Well, for what I mean by enable mirroring, it's internally when the mirror daemon sees via FSMap that mirroring needs to be enabled, it spawns a bunch of threads for those. And adds peer and kicks off all the synchronization for that. Okay, so the way this class is used, and most of the classes here are kind of tried to kept so that it can be tested standalone. So the way you use cluster watcher is via listener. So you provide a listener object and say when something changed, which is like when notify me or call this virtual function when you have mirroring enabled, call this when you have disabled, and peers are added and peers are removed. Okay. So before going into more details, let's see some data structures involved here. We'll go into type.h. So a file system is a CephFS file system, which is like just a name, a string name. Mirror daemon uses a tuple of the file system ID and the file system name. Why we do this is internally when we'll go through all the details, we'll see most of the things are asynchronous. So when so it could be that a file system is getting deleted, which is like equivalent to disable mirroring from mirror daemon's point of view, and it's trying to shut down and back off and doing unmount, and a file system gets created again with the same name. So because of for that reason, we do not only use the the file system name as the ID, but it's like a tuple of the file system name and the ID. So the ID is always unique for a file system. So if you delete a file system and create it with the same name, it will have a different FSID. So we use that internally everywhere. This is basically is just a specification for the file system. It's nothing but just an encapsulation with an additional pool ID. Yeah. So yeah, back to ClusterWatcher. So the user of ClusterWatcher will actually, when it initializes ClusterWatcher object, will give a listener, and it needs to kind of subclass this listener class and implement all these virtual functions. It's like, so it needs to implement, say, what do I do when mirroring is enabled? What do I do when mirroring is disabled? And likewise for, the implementation when PS are added and PS are removed. So that's what ClusterWatcher does. Let's see if anything interesting is there. Yeah, so if you delete a file system, we consider that as, mirroring is disabled. So we will try to back off if, we are trying to synchronize it. And here we actually go and call invoke those virtual functions. Okay, so where is this used? So all this gets initialized when, so if you would have seen main, when we actually kick things off by creating an object of this mirror class, and then we call in init. So this gets everything running, up and running. Init, does basic initialization. We'll come to service daemon, where we actually send updates to the Ceph manager. There's like a blob of data which is kind of like a status for the mirror daemon. So you can say, these. So the blob, what we send to the managers has like what file systems are mirroring enabled and what are the different stats. We just include basic stats like, we have this many directories scheduled for mirroring. And if we encounter any failures, if we recovered from any failures and things like that. So once we are done with all those, we initialize the mon client, and that's pretty much it on the, let's see, where is ClusterWatcher? Yeah. And if you would have seen here, we do an init and then we run. So we block on run. Run is nothing but, subscribe to ClusterWatcher. Subscribe to the FS map ID ClusterWatcher, and then, init, and then we wait until we are stopped, which is like a user termination. So once we are done with ClusterWatcher, everything is kind of asynchronous now. Now we are getting these callbacks. ClusterWatcher is invoking these virtual functions which are callbacks, and that tells us whether mirroring is enabled or not. So what happens is, let me quickly show you. Yeah. So this here we actually subclass the listener class from the ClusterWatcher, and we implement our own implementation, which is like what to do, something to do when something is mirroring is enabled, disabled, peer add, and peer remove. So yeah, let's quickly do what happens when mirroring is enabled. Okay, so once mirroring is enabled, what we do is, again, things are kept pretty much asynchronous here. So how is this driven? Once you subscribe to ClusterWatcher and then block until somebody does a termination, we have these callbacks coming in. So these callbacks are actually queued. So once, just like here, if you see mirroring as enabled, so we have something called a map between so we have this map between the actions for file system and the actions related to the file system. Mirror action is nothing but different types of action. It could be a mirror enabled. It's less like a list. You can say for this particular file system, these are the queues of actions that need to be performed. And all this is driven by a timer object. Okay, so let's quickly see that too. So before that, there are a bunch of config options that actually drive some of these things. So let's see that too. Yeah. So this has been converted to a YAML, which is nice. So we have this CephFS mirror action update interval. So this is like an interval for driving the asynchronous mirror actions. So when we are receiving these callbacks from cluster watcher, we queue them into a list, and there's a timer thread that actually wakes up every, default is 2 seconds. You could adjust it if you want it to be faster, and then executes these actions. Okay, so all that is done here. So what we do is when we actually have mirroring enabled for a file system, we have these context completions that we queue. So the mirror action has something called as an action context. It's like a list of context callbacks. So we queue these context callbacks in that particular list, and the update, the timer thread just goes and just completes these contexts. So all this is again kept asynchronous. So let's see how enable mirroring is done, which is probably the most simplest one. When we get and we have mirroring enabled for a file system, we this context gets completed by the updater thread, and that calls this particular complete the context. So we end up in calling finish. Once that is done, we call enable mirroring. So we again come back here. Hold on. Okay, so here again, what we do is we just initialize something called as an FS mirror class. So we have this FS mirror class that handles mirroring for a particular file system, and the file system is nothing but again a tuple between the file system name and the file system ID. So we kind of initialize that and call initialize that particular class object. And once that is done, we'll see how FS mirror is written. But yeah, once that is done, we call this init, and then we once the FS mirror initialization is done, it calls back here. So here again, things are asynchronous. So once we do an init, we call this we provide it a context completion again, and that on finish is so if you see this on finish is nothing but if you see the class that we are seeing now, this one, when we actually enable mirroring, so the context here is this. So when the context gets completed, we call this gets called, and we internally called handle enable mirroring. So enable mirroring, we just move that particular. If the mirroring failed, we do some things, and and here we actually go into service daemon, and we see if things have failed, we update the service daemon so that can be notified to the Ceph manager. And if we have peers pending, we do an add peer. So if you just follow this, for every particular action, there's a associated context class for it, which drives the asynchronous behavior. Likewise for disable mirroring, restart, if you want to restart mirroring, which we I think do at certain times when for some reason mirroring has failed, we have this, we try to restart it every, not that frequently, but yeah, we have a config for that. So when we try to restart it, we try to disable mirroring and then enable it again. So that again is driven internally by the context classes that we saw. So yeah, the takeaway here is, this all the boilerplates here are basically just to drive up a particular action for a file system which has mirroring enabled, or you're trying to do disable, or you're trying to add peers. So all that is put up here in this class. We do some other things, such as if you see these config options, we have restart mirror on block list, and there's recently added, I think, restart mirror on failure. So if you recall from my earlier talk, it could be that the mirror daemons have been blocklisted, by the mirroring module. that can happen if there's a network hiccup between the mirror daemon and a network hiccup, which causes the manager module to think that the mirror daemon is not responding to its notify messages. It goes and blocklist those addresses. And once blocklisted, there's this again, once blocklisted, we kind of restart mirroring again for those file systems that have been blocklisted, like 30 seconds later. So yeah. Yeah, that's again done by the updater timer thread here, which is like this part. It's nothing much interesting, just figure out from what's the next action that needs to be performed and go and complete the context. And takes care of certain things like blocklisted mirror instances and failed mirror instances, and tries to restart them if it fails. So okay, now we come to the entity that actually does mirroring. So we have this FS mirror class that takes care of mirroring for a particular file system, kinds of is multiplex for handling multiple peers. So right now we support only adding a single peer, but we could probably support adding multiple peers too. So this is multiplexed for supporting multiple peers. So now the interesting thing here is, if you recall from my earlier talk, so there are two index objects that's associated with the mirror daemon, or rather not only the mirror daemon, but the mirror daemon and the manager module, mirroring module. So we have this global index object which lives in the metadata pool for a file system. It's called the CephFS underscore mirror object. That's the global object. And then we have a mirror daemon private object, which is like CephFS underscore mirror dot suffix by the instance ID, which is nothing but the RADOS instance ID. So we use all that here, and we'll see how that's done. So when we kick things off here, we try to connect to the local cluster. Well, the thing is, for the primary cluster, we need the Ceph configuration file and the keyring for the user that's used to mount file systems in the primary cluster. Once that's done, we mount it, and now we do this thing for initting instance watcher, and so we have concepts of. So we have two things here. We have an instance watcher and a mirroring watcher. The instance watcher class is used to handle notify messages for the private index object, which is like the CephFS underscore mirror dot instance ID. And we have this mirroring watcher class that's used to handle notify messages for the global index object, just the CephFS underscore mirror object. Okay, so how's that done? If you see instance watcher, the crux here is, we use the RADOS AIO notify and AIO watch, or rather just the AIO watcher, AIO watch API to establish a watch on a particular instance. So here again, things are kept asynchronous, and there's kind of a state machine. So what we do is first we create an instance. So when we create an instance, you do this AIO operation, which is like an object write operation, and op.create. So there's you can stack multiple operations on a particular object and then fire it off with a single AIO operate call. Okay, so here we do an AIO operate, which just creates. So the MOID here is nothing but, if you see the CephFS mirror dot the instance ID, that's kind of initialized here in the constructor. Here, instance OID. Instance OID is nothing but the server mirror object, which is like server underscore mirror, prefixed suffixed by the instance ID, the Rados instance ID. So we go and create that, and once that is done, we call register watcher. Register watcher establishes a watch on that particular object. So for that, we use the watcher class. Register watch does an AIO watch on that particular instance object. Likewise, for the mirror watcher, it does the same thing. The only difference being, it establishes a watch. It doesn't need to create it because the manager module creates this particular, when you enable mirroring on a file system, the manager module, it creates this CephFS_mirror object on in the metadata pool. So we need not create that. All we need to do is to establish a watch on that. So we call register watch. And once that is done, so whoever sends a notify via that particular object, we get notified here, where we call handle notify. So for the instance watcher, the notification message, this is not binary, because we send these from Python. So it's like ASCII based. So we send a JSON in the as the notification payload, and the JSON has basically two things, right? The directory part to operate on, and the mode. So recall from my earlier talk again, the manager module kind of sends these acquire and release messages to the mirror daemons. So the acquire is like assigning a particular directory to a mirror daemon, and release is like it probably wants to reassign that directory to another mirror daemon, and it wants the mirror daemon which is currently synchronizing this directory to back off and not worry about the directory anymore. So we get these JSON with the appropriate path and the mode. Once that's done, again, we are all kind of listener based here. So we have this instance watcher where once we get a notification, we call these virtual functions, which are kind of somebody has overridden the caller has subclassed this and overridden these particular virtual functions for their implementation. So we do that here. We only support basic acquire and release modes. Is like acquiring a directory, releases backing off, not to worry about that directory anymore. And this is all tied up in the FS mirror thing. So let's quickly see. FS mirror. Yeah. So we have this. We kind of derive from these from the instance watcher listener class. I call it snap listener. Okay, it should be called directory listener because we are not really listening on snapshots. But yeah, it's kind of operating on snaps for the directory. So it's kind of doesn't hurt to kind of rename this as listener to be really consistent with what we are doing, typing based. So yeah, we have this listener class again. We have the implementation. We override the virtual functions, and we call this handle acquire directory when we want to acquire a directory. Otherwise, likewise, what to do when a directory wants to be released. So this is all again tied up in FS mirror class. Again, so this is when we init an FS mirror. So when we actually initialize an FS mirror object, when you create an object and call init, it does all this. It creates the per private index object, establishes a watch on it, then establishes a watch on the global object, and that's pretty much it, I guess. So this can be followed by a state machine, a simple state machine. So first we call init instance watcher. That does the init of the instance watcher, what we saw. Once it creates the object and establishes a watch. There's the callback. We call mirror watcher. We initialize the mirror watcher, which is just like establishes a watch on the mirroring object. Once that is done, once that is done, we invoke the callback, which is like goes back into the mirroring source file. And once all that is done, we are kind of ready to handle any notifications from the mirroring module. And what happens is we have these add peer and remove peer interfaces. So remember that the mirror module, the mirror source kind of has this list of actions to be completed. So one of these actions could be adding a peer. Peer is, so we saw this in FSMap last time. .h. Yeah, peer is nothing but, you have this UUID and some information about the remote endpoint, which is like the client name, cluster name, and the FS name. So when we get that, we kind of, create replayers for that. So, it's like, it's like there are a bunch of threads assigned for a peer that is controlled by the, let's see. Yeah, CephFS, mirror, max, snapshot, sync. Sorry, not that one. Let's see where it is. Directory scan. I can't seem to find it. Init replayer. Peer replayer. Oh, sorry, that's in peer replayer. Okay, not yet reached there. Okay, so once we have that, once we add a peer, we call this init replayer, which nothing is but initializes the creates an object of the peer replayer class. So peer replayer class is where all the logic for synchronizing a particular snapshot to the remote target is implemented. So here's this is actually multi-threaded. So we assign a bunch of threads for a particular peer. So right now we support only a single peer. So if you add a peer, add multiple peers, we kind of assert here. We probably would want to remove this, sooner or later. But yeah, so again, remove peer does nothing but whatever was initialized the peer repair class, just go and shut down it. So nothing much in that. Again, so when we get these handle acquired directory, we get these callbacks from instance watcher class, which tells us that this directory has been now unit acquired this directory or released this directory. Kind of everything is kind of you'll see the service daemon thing again and again in between in these places. So it's like updating a metadata blob, which is managed by service daemon, so that notes how many directories have been scheduled to this mirror daemon. Likewise, you'll see in release it just does the opposite, which is like it sets now we have these many directories to handle. And the service daemon kind of periodically, pushes all these metadata blob to Ceph Manager. Once want to acquire a directory, call this add directory interface in the peer replayer, and we'll see peer replayer in a while. So yeah, peer replayer. Okay, so the interesting thing here is so I mentioned that for connecting for the mirror daemon to talk to the remote file system in the remote cluster, it either needs the Ceph configuration file of the remote cluster and the keyring and things like that, or we have this Bootstrap thing, which so we create a Bootstrap token on the remote cluster and then import it in the primary cluster. What happens with Bootstrap import is, I think we didn't cover this in the last talk. I think we didn't reach that. So bind gr mirroring snapshot bootstrap import. Okay, so let's see. Create is nothing but we create a token which has so the token would have we base64 encode XX encode it, but it would have the cluster FSID, the file system name, and this needs to be done on the remote cluster. It would have the remote cluster's FSID, the FS name, the user. So you create a user here. We use the FS authorize to create a user, and then we fetch the keyring key, and we have this again. Sorry. Okay, so it's just a dictionary based off, all the minimum things that are required to connect to this particular cluster and file system, and the mon host. Once that's done, we kind of, create a base64 encoded string for that, and that becomes the token. And the interesting part is when we import it in the primary cluster, we just decode the token. Once that's done, we have the required details. We call into peer add. So what's done is all these, the keyring and such are kind of stored in the mons. So it uses the mon config store for that. Let's see. Peer add. Okay. Quickly see peer add. Yeah. So we do some basic checks. We covered this. We kind of try to set up, an exhater on the peer's root, file system's root, so that if two clusters try to do a peer add on the same peer, only one succeeds because it uses that exhater create flag for when creating an exhater. Once that is done, yeah. So this is the point where I actually go and do we do a config set. So we save these details into the mon config store. The key here is we have this peer config key, which is like slash peer config key, peer file systems, and the peer UUID. So recall that every peer has a UUID associated with it, so that becomes a distinct key for that particular peer. And we save all these details. So if you see where config set is done, we set these config set file system and do a set of the remote conf. Remote conf will basically we just have the mon host, the username, the key, and something called as a site name. Site name is just we use a user string that can be anything that's used to identify this particular remote site. It's not used anywhere internally in the mirror daemons nor in the manager module. It's just for the user to make sense of. Okay, so what we do here is we try to connect back to the mirroring module. So we try when we initialize this peer replayer, we try to connect to the remote cluster and mount the file system. So we try to fetch these required details, creds from the mon store, mon config store. We do a mon command, get those keys. Once if we get something, decode it, and then for this connect interface, we provide the mon host and the CephFS key. The client name, the host and the CephFS key. And it's nothing but once we have those mon host and keys, we set them in. We override those in the ccd conf, ceph context conf. So here we set the mon host and then the key. So with this, we do not require the remote clusters config, ceph config file, and the key rings to be present on the, in etc ceph. We don't require that. We do with the Bootstrap, we can override that and save all these details in the mon config store. And the ceph mirror daemon reads it back and uses it. Okay, so as I said, every peer has a specific number of threads assigned to it. So you have these multiple threads trying to synchronize snapshots for a directory. A thread handles a directory. So it's like we have a list of directories for which the snapshots need to be synchronized. So each thread is associated with a directory. In a sense, it tries to pick a directory for which snapshots have been synchronized. So you can have 10 directories and just 3 threads, but each of them will have just handle one. So it's not the thing that has been taken care is 2 or more threads cannot handle a particular directory, because in the end we use the incremental based sync that does snapshot one at a time. Or even the old-fashioned remove and bulk copy does one snapshot at a time. If multiple threads were to synchronize snapshots, that would probably be bad. That would be disastrous, because multiple threads would be copying snapshots for the same directories to the remote file system, which is not great. So we do snapshots one at a time for a directory. Let's go back to where we are seeing this Max concurrent directory syncs. Okay, first one. Yeah. So yeah, we default is 3. You could probably increase it based on how beefy your machines are and how fast do you need synchronization. But the main point is we have a bunch of worker threads for handling snapshot synchronization. So we have seen these interfaces, or rather seen the FS mirror class call these interfaces. The add directory just adds it in the queue. Remove just is the reverse, is like just remove it from the queue. But if synchronization is going on, you ask it to back off, and then we remove it. Most of the things here are pretty straightforward. Not really need to go into each implementation details. There's one thing that we do here is, once a thread picks up a directory for snapshot synchronization, we do an f lock on that directory on the remote file system. The reason we do that is, recall that we probably want to support multiple CephFS mirror daemons synchronizing congruently at some point of time. So say a particular directory path is assigned to a mirror daemon, and that one of these threads are kind of actively synchronizing directory snapshots for it. Another daemon comes up, and the mirror daemon figures out that this particular directory is we can probably shuffle it to the other mirror daemon so that for balancing. And it happens that this mirror daemon is for that particular file system is currently synchronizing that particular directory, snapshots in that directory. When these acquire and release calls, they are not blocking calls, right? So a release call may come in, and internally, when we actually schedule the removal of a directory or rather release of a directory, we act back saying that it's done. But internally, if a synchronization is going on, it needs to back off later. We do not block before we can release that particular. We finish or interrupt synchronizing that directory. So from the mirroring module point of view, the mirror daemon has kind of noted that this directory needs to be released, and now it can go ahead and assign it to another mirror daemon, and that mirror daemon now notes that it needs to handle the snaps for that directory. So the flock here ensures that we don't run into a case where we are backing off from a mirror daemon is backing off synchronizing for a directory, while the other mirror daemon starts synchronizing that a directory. So before we scan snapshots and synchronize them, we take a lock, exclusive lock, or a non-blocking lock on the remote on the directory on the remote file system. So if the other mirror daemon were to try to pick that directory and try to synchronize it, but this mirror daemon is just backing off, it wouldn't have released the lock or just about to release the lock. So we don't run into a case where one mirror daemon is kind of backing off, completing a particular IO operation, and the other mirror daemon does the IO operation again. We don't know what will happen. So we guard all those by an exclusive lock, and it's non-blocking. So if the flock call returns and that we might block, we retry it later. which kind of tells us that it's probably logged by another mirror daemon, and sooner or later it will probably release it, and when we acquire the lock and do the normal operation again. Once that is done, that's the main part. Yeah. Then the other interesting thing is before for a particular directory, so the mirror daemon can identify snapshots that have been deleted and renamed. So you can have some of the snaps. You can rename a snap, and delete some snap, and mirror daemon can identify that. If you rename a snap, it's not like the mirror daemon would delete it first and then copy it again. This is all based on snap IDs. So we have an interface to fetch the snap ID for a particular snapshot. And with that, we build a map, key being the snap ID and the value being the snap name. And we do this for the local and the remote file system for our directory. And we can figure out, if a snapshot. So before we build the snap, so how do we know that a snap has been deleted? Because the snap IDs on or renamed, because the snap IDs on the remote file system for a directory would be different, because that's another cluster. So what we do is when the mirror daemon synchronizes a snap, we use the mksnap call to create a file system. So when it has synchronized all the data, we do a CephFS, and these are the things we added for the mirror daemon. We added a snap metadata, which is it's just a free-flowing key value pair that you can store that is actually attached to a snapshot. It's just like a free-flowing key value pair. Snap metadata, and then we have the snap info, which is a call, which gives you the snap ID and the snap metadata, if any, that was associated for the directory, for the directory snapshots when creating a snapshot. So what we do is, so we'll see here. Okay. So what we do is, while creating a snapshot, once you have transferred all the data, you store the for the snapshot that is being transferred, that is being synchronized. It has a snap ID on the primary file system. We stored this particular ID in the metadata on the remote snap metadata. If it had ID 2 on the primary file system, when we take a snap, the snap on the remote file system can be anything, can be 10, can be 12, any number. But to identify these deletes and renames, and to ensure that we start from the correct snap, we store the primary file system's snap ID for that snapshot, which is like 2 here, on the metadata on the remote snap. So when we do this build snap, so when we do build snap, so when we build this snap map, for the primary file system, when we are building this snap map, which is less like a map between, so we'll see here. Sorry. When we build these snap map, you'll see it's just a map between an integer and a string, integer being the snap ID. For the primary file system, it's the actual ID, the snap ID, which is the ID of the snapshot. For the remote file system, it's the ID from the metadata that we stored. So the ID here is not the snap ID of the snap on the remote file system for that directory, but the actual ID of the metadata, which is ID stored in the metadata, which is nothing but the ID of the snap ID of the primary snap ID of the snapshot in the primary file system. So once we do that, we now have this map. So we can compare this map. If a snap ID is missing from the local snap map, but available in the remote snap map, that means it's deleted. If the ID is same but the name is different, that means it has been renamed. So we can just do a a rename call on the remote file system and rename that particular snapshot. So once we do the snap map, now we need to figure out. So this code, what we have here is the incremental based synchronization that is now under review as a PR. The master code would be a bit different because the incremental part is not there, and we do just the rmdir, remove the contents, and then copy the whole thing again. But here we have this incremental snap. So what we do is, based on the snap map, looking at the snap map, we figure out what's the next snapshot to start synchronizing from. That you can infer it from the local and the remote snaps. Once that's done, we check if we could probably choose incremental snap. Now, how is that done? So what is done is, so we have a new Xadder for this. Let me quickly do that. Yeah. So in that PR, we introduce this ceph.mirror.dirty snap ID. So before we start synchronizing data for a particular snapshot, we set this Xadder on the directory on the remote file system. That is the directory of that is the snap ID of the snapshot that is currently being transferred. So initially, when we are transferring the first snap, this Xadder is not available, which means if the Xadder is not available, we need to do bulk copy because there is nothing to compare to, which is like equivalent to starting with the first snapshot. So that needs to be a bulk copy. So the bulk copy, before starting the bulk copy, we'll set this Xadder on the remote directory. We'll do the transfer, and then we'll do a snap. When we come back and choose another snapshot to synchronize, we do this comparison based on the what's available as the Xadder value in the remote directory, and what are the snapshots. What is the snap ID we are transferring from? So if there's a match between the snap IDs on the remote directory, which is the value of the Xadder in the remote directory, if it matches one of two, if it matches so with incremental snapshots, we have what we do is we'll have we pick two snapshots. So one that is already transferred to the remote, and the other that is currently being transferred. So they will have snap IDs. So if the Xadder value on the remote directory matches one of these snap IDs, we can do incremental transfers based on local comparison, which means we need not compare the current snapshot data with the remote file system data for a directory. We can infer it locally by comparing two snapshots which are in the local file system. That's because the snap ID tells us that the data. So the idea of the snap ID, the value of Ceph mirror dirty snap ID is it identifies it tells which the data under this particular directory is associated with what snap ID. So it could, if it's associated with the snap ID of the older snap, it's fine, because then again we can do local comparison between the earlier snap and the next snap. If it's so it could happen that we are transferring data for a particular snapshot, which means setting the snap ID for the dirty snap ID, etc. And then the CephFS mirror restarts. Once it restarts, we get this snap ID which now matches the current snap ID. We can again choose. We can again do incremental transfers based on local comparison, because the snap ID matches. We know that the data on the remote is now somewhat incomplete, but it belongs to the data for the current snap ID. The catch here is we need to ensure that the snapshot we are comparing from is also, the data was transferred to the remote file system based on, we need to ensure that before the CephFS mirror daemon was restarted for some reason, the snap ID, the data on the remote file system is transferred by comparing two snaps, and after restarting, we are still comparing the two snaps. That needs to be ensured, because if we choose a different snapshot, now you really can't trust the data on the remote file system directory. So we do all these checks. All those checks are based on the dirty snap ID, etc., and the local and remote snap maps. So with this, we can kind of figure out that if it's safe to go ahead with incremental transfer based on local comparison. If for some reason we cannot, say we are transferring a snap by comparing to snapshot X before, which is a snapshot that was transferred, snapshot X and now snapshot Y. Then the CephFS mirror daemon is restarted, or the mirroring is disabled, and then when it comes back again, CephFS mirroring is enabled again. The snap X doesn't exist. Snap X doesn't exist. So if you're comparing to the snapshot before that, obviously we can't use incremental snapshot based on local comparison. In that case, we use incremental snapshot based on remote comparison. Just like comparing the snapshot in the primary file system with the actual data on the remote file system under that directory. Uses the same logic. The logic is same. It's like comparing data between two snaps, or comparing data between a snap and the data on the remote file system directory. The logic is same. It's just that we use the correct mount variable, which is like either points to the local file system, and the path is the last snapshot, or it points to the remote file system and the path is the remote file system directory. And all these is again, we based on the recently introduced, or rather almost ready to merge at calls based APIs. So we kind of open a file descriptor on the snapshot directory and do add base calls relative to that particular FD. So and this is not yet merged. It could happen that when we are transferring a snapshot, somebody deletes a snapshot, creates it with the same name but entirely different contents. If we do path-based, pure path-based operation, we'll kind of, there might be a case where we might, just transfer the incorrect data because we are just doing path-based operation. But with these all FD-based, add-based calls, you have the inode pinned in memory because we have that FD open, and we do everything related to that. So this, peer replayer is, so that's the most, thing to be discussed about peer replayer. The crawling of the file system data is, it's nothing interesting. We just crawl, do a walk of the file system, and then compare and sync. Yeah. I think I covered most of the parts. Let's see. Service daemon is pretty simplistic. Just uses the manager, or rather the APIs provided by Radas to periodically update data, the metadata blob to Ceph manager, and we kind of show, and we have an interface in the manager module to kind of pretty print the JSON, the blob, which is sent by these mirror daemons. I guess that's it. Yep. Thanks, guys. Thanks for attending the code walkthrough.